Now for example 2.4.8, we are still doing hypothesis testing on averages. So it says, a past study claims that adult Canadians spend on average 18 hours a week on leisure activities. So this is the supposed average for all of the Canadian adults, so that's the average for the population. A researcher wanted to test this claim, so he thought maybe it's not exactly 18 hours per week. She took a sample of 10 adults and asked them about the time they spend per week on leisure activities. The responses in hours are as follows, and here are the hours that they spend per week on leisure activities. Assume that the time spent on leisure activities by all adults is normally distributed. Using the 5% significance level, can you conclude that the claim of the earlier study is true? First step, we define the variables. So, it said that a past study claims that adult Canadians spend on average 18 hours a week on leisure activities. This is the average for the population, so I will note this as mu equals 18 hours. I want to test this claim. What do? I take a sample of 10 adults. This is my sample size. This will be my small n equals 10. From these 10 adults, these are the responses of the number of hours per week that they have leisure activities. So I got 14, 24, 5 hours, 22 hours, 38 hours, etc. From this data, when I have raw data like this, I will be able to find two things. I will be able to find the average from the data, and I will be able to find the standard deviation. Now, don't panic. I was supposed to show you how to calculate average and standard deviation on your calculator. Now, either you can do it by yourself, but in an exam question, I will give you these informations. So from this data, you can calculate the average. That's the average of the sample. It gave me an average of 25.7 hours. So you can see that this is different from the 18 hours that was supposed to be my average. From the sample, I actually got 25.7 hours. And also from this data, I can calculate a standard deviation, which I call S, which got me 9.04 hours. And finally, it says to use a 5% significance level to test the claim that the average of 18 hours per week on leisure activities is true. These are my information. First thing, I write out my hypotheses. My first hypothesis is the null hypothesis, H0, which says that the average time spent per week on leisure activities is 18 hours. That was the given supposed status quo information. I am testing the claim, saying I'm not exactly sure that's right, okay? Without suggesting anything, it just wanted to test the claim that it's really 18 hours. So in the question, it doesn't say I think that it's higher or I think that it's lower. So that's another type of hypothesis. I can say that the alternate hypothesis is just saying it's different than 18 hours. So I'm actually testing both sides. It might be higher than 18 hours. It might be lower than 18 hours. Second step, conditions. So since I'm dealing with averages, normally I test small n is bigger or equal to 30. The problem in this case is that small n is equal to 10. That is not bigger or equal to 30. So I have a second condition, which is my data normally distributed? I will test that in my example. Where does it say that? I am trying to find it. Assume that the time spent on leisure activities by adults is normally distributed. So it says in the question that my data is normally distributed, so I am okay. Oh, I didn't write critical points here, but it is critical points. So now I draw my curve. Okay, I draw my normal curve. Normally it's a normal curve, but here this is actually a student distribution. Why is this a student distribution? It's because as soon as I do not have sigma and that I have a standard deviation from a sample, the S being the standard deviation from my sample, I have to automatically use student distribution. Remember, that's the same for confidence interval estimates, but it doesn't change much. In the middle, I have my average, my supposed average for my population, which is 18 hours. I want to test that my true average is different from 18 hours. The difference from the two examples that we did before is that before we were testing that the average was bigger or lower. Here, we just want to test that it's different from 18 hours. So we're going to test on both sides. Okay, so since we're testing on both sides, I have to take my significance level, which is 5%, and I will split it up. So I have 2.5% on each side. Since I have 2.5% on each side, I can go through my student distribution table and find the t-score. How do I find the t-score? I have to have my percentage. This is my alpha. It's my 0.025, my 2.5%. And I also need my degree of freedom. Remember that the degree of freedom is always the sample size minus 1. Since my sample size is 10, 10 minus 1 is 9. I use 9 and 0.025 in my table. I find that t is 2.262. Once I have this information, again, I calculate sigma of x bar and my c, always the same thing. Sigma of x bar is sigma over square root of n. Here, remember that I do not have sigma. Sigma is not given in the information, but I have my standard deviation from my sample, which is S. So I will use this information then. So 9.04 over square root of n, which is square root of 10 in this case, I get my sigma of x bar. And I can calculate my critical points. Remember here that we are testing that I have values different than my 18 hours. So I will test 2 critical points. What that means is that this formula is now mu. Before I had plus t times sigma of x bar. Now I need to find 2 values. I have a positive t and a negative t. So I will be testing plus and minus t. So 18 being my average from my population, plus or minus the t student t-score, which is the 2.262, times sigma of x bar, 2.86 over here. All of this gives me 2 numbers because I'm doing 18 plus 2.262 times 2.86, and I'm also doing 18 minus this calculation right here. Gives me 2 numbers, okay? What do those 2 numbers mean? The 11.53 is my critical number to the left, and my 24.47 is my critical number to the right. If I am in those zones right here, it's like saying that my 18 hours here is exaggerated. It shouldn't be considered the real average because I am in the 2.5% exception on each side. My decision rule fitting with this information right here is to reject H0, saying that my average for the population is 18 hours per week, if I am in both those colored zones. So if X bar is smaller than 11.53 hours, how did I get that? The first critical number is 11.53, so either I'm below or I'm higher than my second critical number, which is 24.47 hours. So I will be rejecting my hypothesis, H0, if X bar is below my first critical number or higher than my second critical number. Finally, I look at what I have. What is my X bar? My X bar was my average with my sample. It gave me an average of 25.7 hours, which is different from the 18 hours. Is that too far off to say that the 18 hours doesn't make sense? We'll check. 25.7 hours, which was my average from my sample. It is higher than my 24.47 hours, which was a critical number, which means that it is in this 2.5% zone. So it's like saying my sample gave me a number fairly different than my supposed 18 hours over here. So I will be rejecting H0, I will reject H0, and rejecting H0 means that I do not agree that my average for the population is 18 hours, so I am probably saying that my real average is not 18.